Evaluate the integral of 10x squared plus 10x, all divided by x squared minus 4 times x squared plus 1. And this will be from 0 to 1. The first question is the denominator degree more than the numerator degree? And the answer is yes. You can't just think about the denominator degree being 2. It's x squared times x squared, which will be x to the 4th. Highest power on x in the denominator. So you're good to start the method. You're supposed to start the method by factoring the denominator. Well, thankfully, it's already factored for you. Or is it? So you have x squared minus 4 and x squared plus 1. It actually is not totally factored. The x squared minus 4 is the difference of squares. It factors as x plus 2, x minus 2. The x squared plus 1 is an irreducible quadratic. You can't do anything with it. So actually it was factored but not totally factored. But now that we have that, we can begin. It's very important that we recognize which of the three types of terms that we have. The three types are a linear term that's to the first power, a linear term that's to a higher power, and the third is an irreducible quadratic. So what are we looking at? Well, the first two we have here actually are irreducible, are linears that are raised to the first power. These guys here, both of them are linear to the first power. The other guy is an irreducible quadratic. Identifying that is very important because that tells you how to decompose. So how do you decompose? Well, it's going to be some a over x plus 2, some some a over x plus 2, some b over x minus 2, and some cx plus d over x squared plus 1. Sorry, the limits are from 0 to 1. I'm not sure what happened here. Some typo, I guess. Okay, so remember, cx plus d always goes above an irreducible quadratic. Okay, here we go. We need to now chase down the constants. What you do is you ask yourself, what is the fraction missing in order to create the common denominator? The first fraction, a over x plus 2, is missing the x minus 2 and the x squared plus 1. The b fraction is missing the x plus 2 and the x squared plus 1. Now be careful here. The numerator of the last fraction, cx plus d, needs to be multiplied by the x plus the 2 and the x minus 2. And then don't forget that you have your left-hand side here, 10x squared plus 10x. Okay, great. So we have our original numerator, and then we have our numerator that we get once the fractions are combined into one. These guys should equal to each other. And what you need to do is choose the x values that will make the denominator 0. After you do that, if you exhaust that, then you should go down this list of convenient x values in decreasing order. Start with 0, then 1, and then 2. Okay, if you need to go that far. So first up, we're going to let x equal 2. It will make any term that has x minus 2 in it go away. You see this first term here, a, has an x minus 2 in it. So it's going to go away because that guy is a 0. The last term has 2 minus 2 in it once we plug in the 2. So that all dies away. And you're left with this middle term here. And don't forget, you're also plugging into the left-hand side. 2 squared is a 4, so 40. Plus 20 on the left-hand side, 0 for the first, 0 for the last. In the middle, 4b and a 5. So 4b5, that's 20b. 60 is 20b. It tells us that b is 3. Great. What do you think we're going to choose next? We're going to let x equal negative 2. It's the other thing that makes the denominator 0. We plug it in, be careful, and when you plug it in, you're going to kill any term that has an x plus 2 in it. So here we have a 0 here, and then over here we have another 0. So those guys die out. On the left hand side, you're looking at a 4 again. So that's a 40. But this time minus 20. And the term that survived is the a term. You'll get a negative 4 and a positive 5 multiplied together times a. That'll say the fact that, that'll basically be the fact that 20 is negative 20a. Or that a is negative 1. Okay, great. So we have that. Now we need to work on trying to find c and d. We've exhausted our terms that make the denominator 0, our x values that make the denominator 0. So we need to go down this list choosing other x values starting with 0, since we haven't used it yet. If we let x equal 0, the left-hand side is a 0. On the right-hand side, something nice happens because this c ends up not being a part of the problem because it gets multiplied by 0. We'll still have the a and the b floating around, but we know what they are. We know that a is negative 1, and we know that b is 3. So we plug in, and we end up with a negative 2a and a positive 2b and a negative 4d. Here's the negative 2, and here's the positive 2, and that's all times d. So negative 4d. But knowing that a is negative 1 and b is 3, we can plug them in, and we have 2 plus 6, or 8, minus 4d, or that 4d is 8, so we know that d is 2. Great. Now we're going to let x equal 1. Plug it into the left-hand side, we get 20, 10 plus 10. On the right-hand side, we now know a, b, and d, so we can find out the final constant, which is c. Carefully plugging in, what happens is you get a negative 2a, a positive 6b, and then a negative 4 gets multiplied by the quantity of c plus d. I'm sorry, negative 3. I said negative 4. I'm sorry, negative 3. But knowing that a is negative 1 and b is 3 and d is 2, we can plug them in. And we'll get that 20 is 2 plus 18 minus 3 times the quantity of c plus 2. Or that 20 is 20 minus 3c distributing minus 6. Or that, putting these together, 14 minus 3c should be 20. Shipping this over to the other side here, subtracting it, we get that 6 is negative 3c. Dividing by the negative 3, we get that c is negative 2. So now we have all the constants. Great. Our job then is to put them all back together and integrate. Remember who was on top of what, and plug them back in. So a was on top of x plus 2, and b was on top of x minus 2, and negative 2x plus 1 was on top of x squared plus 1. We're integrating from 0 to 1. When you have the irreducible quadratic term and the denominator's derivative is not exactly the numerator, or when the quadratic is more complicated, then you can get your way out of it. Or when it is exactly the numerator, you can get your way out of it. When it's not, though, like this, when you have an x squared plus an a squared kind of situation, then what you should do is split your fraction into two parts. Have it as negative 2x over that x squared plus 1 and a positive 2 over that x squared plus 1. Here's what's going to happen. We're going to integrate now these all individually. We're prepared to integrate 3 of them without too much trouble. The third fraction here could be a bit of trouble. We can go get a U-substitution for that, because conveniently du is exactly 2x dx. So we'd have du over u. Yes, there's a negative there, but I'm just going to carry that negative forth. I'm just going to focus only on integrating that function there and just carry the negative. So we get the natural log of u. Okay, and so that's going to be minus the natural log of x squared plus 1. Okay, then we have a minus the natural log of x plus 2 and a positive 3 natural log of x minus 2. And now this last guy is arctan's antiderivative times 2. Right, the integral of 1 over 1 plus x squared is the arctan of x. So you're good to go from 0 to 1. We plug a 1 in. We get negative log 3 plus 3 log 1 minus log 2 plus twice arctan 1. Just be careful there. You plug a 0 in, you have minus log 2 plus 3 log 2 when you do the absolute value. Minus the log of 1 plus twice the arctan of 0. Okay. The arctan of 1 is asking the question, what angle do you plug in the tangent and have it spit out a 1? It's pi over 4. The arctan of 0, what angle do you plug in the tangent and have it spit out a 0? It's 0. Okay, we'll have minus log 3. Log of 1 is 0. Anytime that guy shows up, we know that's going to 0 out. So we have minus log 3, minus log 2. This 2 and 4 can cancel, basically. We'll end up as pi over 2 for that. And then from the other side, distributing the negative across, we get plus log 2 minus 3 log 2 plus nothing there at the end. Now what's going to happen here, this minus log 2 and this plus log 2 wipe each other out. The pi over 2 is part of it. Then we have minus log 3. Minus 3 log 2. This guy survives and this guy survives. Now how we should treat this is really, I think, to factor out the negative. We have pi over 2 minus the log of 3 plus 3 log 2. Okay. Take this 3 up as the exponent and call it the log of 3 plus the log of 8 with a minus sign out front. And then you can put them into one log by combining them using the log of 3 plus the log of 8 is the log of 3 times 8, or 24. So our final answer, pi over 2 minus the log of 24.